Okay, now it's time to put it all together. Now you should be able to identify a name or get the formula for any ionic or molecular compound. Previously, you should have learned the naming and formula rules for simple ionic compounds, multivalent ionic compounds, complex ionic compounds, and molecular compounds. If you missed any of these or still feel weak, go back and review them individually before moving on. Each of these types of compounds should have been easy enough to master while you did them one at a time, but now what do you do if you're given a random name or formula and have to find the corresponding formula or name? The first thing you have to do is determine whether you're dealing with an ionic or molecular compound. The simple question you must ask yourself first is there a metal or ammonium acting as the cation? To answer this question, you'll determine what set of naming rules you'll use. Since the cation comes first in any name or formula, look at the beginning of the name or formula. Is there a metal? If so, it's ionic. Remember, the one exception is ammonium or NH4+. It's the only complex cation, so if it's there, you're also dealing with an ionic compound. If the compound is ionic and you're given the formula, getting the name is the easy part. Name what you see on the periodic table and don't worry about indicating how many of each atom there is. There's no prefixes. Those are only for when you have molecular compounds. The one type of name you'll have to add to is when the metal is a transition metal with more than one possible charge. Here you'll have to determine which one it is by seeing how many negative charges are given with the anion, then balancing the positive charges for the metal. The charge on the metal is indicated by a Roman numeral in the name. If you're given an ionic name and have to come up with the formula, the job is a bit trickier. Now you have to do some complex math involving adding numbers up to 10. Not too hard. Remember, positive charge has to equal negative charge in the compound. If you need more than one of an ion, you use a subscript number behind the ion in the formula to show how many are needed. If the ion is complex, put brackets before using a subscript outside it. So that's it for ionic compounds. Let's go back to your original question. Is there a metal or ammonium acting as the cation? If the answer is no, in other words, if you see all nonmetals without NH4+ or ammonium, then you have a molecular compound on your hands. So, what if you have the formula and need to get the name? Easy. Name what you see, remembering to change the end of the last name to IDE. Then use prefixes to tell how many of each element is in the formula. Remember, mono, di, tri, and so on? If only life could be so simple. There are also those ones you have to memorize, so don't follow the rules. They are water, hydrogen peroxide, ammonia, sucrose, glucose, methane, propane, methanol, ethanol, and hydrogen sulfide. You also have to memorize the molecular elements. Remember Haber-Finkel or something like that, phosphorus, and sulfur. If you've got a molecular compound name and need the formula, your job is easier. The prefixes tell you how many of each element you need. You do this by using a subscript number behind the element. Okay, let's do a few to practice together. Okay, you're given calcium phosphide. Is there metal or ammonium? Yes, so it's ionic. You're given the name and you need to find the formula, so you have to balance the charges. Look on the periodic table. Calcium has a 2+ charge. Phosphide has a 3 negative charge. To balance, you need 6 positives and 6 negatives. This will take 3 calciums and 2 phosphides, making the formula Ca3P2. Let's try N2Cl4. Is there metal or ammonium? No, so it's molecular. You're given the formula and you need the name. You can start with nitrogen chloride and add prefixes, or just notice that there are 2 nitrogens, so it's dinitrogen, and there are 4 chlorines, so it ends with tetrachloride. NH4NO3. Is there a metal or ammonium? Yes, so it's ionic. You're given the formula and you need the name, so you just name what you see the way it appears on the periodic table. Note, these are both complex ions, so you have to look in the table of polyatomic ions. Ammonium nitrate. You're given the name tin 4 oxide. Is there a metal or ammonium? Yes, so it's ionic. You're given the name and you need the formula. You need to balance the charges. Remember that the Roman numeral shows the charge on the metal, so tin has a 4+ charge. Oxide always has a 2 negative charge. To balance the negatives with positives, you need 2 oxides, so the formula is SnO2. Next one, phosphorus trifluoride. Is there a metal or ammonium? No, so it's molecular. You're given the name and you need to find the formula. If there isn't a prefix, it means there is one. 1 phosphorus and 3 fluorides gives you PF3. AlBr3. Is there metal or ammonium? Yes, so it's ionic. You're given the formula and need to find the name. Just name what you see on the periodic table. Aluminum bromide. COPO4. Is there a metal or ammonium? Yes, so it's ionic. You're given the formula and need the name. Name what you see. Cobalt phosphate. But cobalt is a transition metal, so the name needs to have a Roman numeral to show the charge on the cation. On the periodic table, cobalt can have a charge of either 2+ or 3+. So which is it? You have to first look at the negative ion. In this case, it's a complex ion, phosphate. Phosphate always has a charge of 3 negative. Since there's only 1 phosphate, there are 3 negatives. There must be 3 positives. Since there's only 1 cobalt, it must carry the 3 positive charge. It's cobalt 3+. The name becomes cobalt 3 phosphate. Last one, ammonium silicate. Is there a metal or ammonium? Yes, so it's ionic. You're given the name and need the formula. Balance charges. Look on the table of polyatomic ions. Ammonium is NH4+. Silicate is SiO3 2 negative. 2 ammoniums are needed to balance the silicate. Put the NH4 in brackets and a subscript 2. Bracket NH4, bracket 2, SiO3. One last point before you go and practice your naming. There are no rules in Science 10 for the compounds and formulas you have to memorize. Make cue cards or a self-quiz and practice to know water, hydrogen peroxide, ammonia, sucrose, glucose, methane, propane, methanol, ethanol, and hydrogen sulfide. You also have to memorize the molecular elements. Hydrogen, oxygen, bromine, fluorine, iodine, nitrogen, chlorine. That's Haber-Finkel. You also have to know phosphorus and sulfur. These ones don't really have rules, you just gotta memorize them. Good luck!